Hello, students. Myself Swayam, and I am currently pursuing my MBBS at AIIMS Bhubaneswar. So, we'll be dealing with part two of Halogens and Haloarines previous year question discussion. So, in part one, we had covered till question number 15. So, we'll be looking forward, looking from question number 16. Okay. So, let's start with question number 16. Just a minute. Okay. So, the question number 16 asks, in an important chemical method to resolve a racemic mixture makes use of the formation of. Okay, just a minute. There is a racemic mixture. Okay, what do you mean by racemic mixture? Racemic mixture is a mixture of the D and L form of a compound. The optical isomers D and L form are mixed together to form a solution or form a mixture. That mixture is called as racemic mixture. That racemic mixture can be fully racemic or partial racemic. Fully racemic means D and L are equal in quantity, but partial racemic means partial racemization or partial racemic mixture means D and L are not quantitatively equal. Okay, so according to the full racemic mixture, that is complete racemization, there will be no optical activity because D and L will cancel each other. But in partial racemization, there will be optical activity because they are in not equal in proportion. So they can't cancel out each other, right? So racemic mixture that is partial will show optical activity. Okay. So if we use a chemical method to resolve racemic mixture, means to divide racemic mixture. So what will be the product? What will be the final output? There will be the formation of T and L form. There will be separation of D and L form. And DL and L form are enantiomers, diastereomers, racemates, or mesocompound. They are diastereomers. So option C is the correct option. Okay. So an important chemical method to resolve a racemic mixture makes use of the formation of diastereomers, that is D and L form. Okay. So racemic mixtures are resolved by the formation of diastereomers. Enantiomers have same physics. What is the difference between enantiomers and diastereomers? Enantiomers have same physical and chemical properties. Okay. But diastereomers have different physical and chemical properties. Okay. So question number 17 we'll see. The process of separation of a racemic modification into D and L enantiomers is called. Okay. Here the same thing is given in a different language. Okay. The process of separation of a racemic modification into. Okay. What is the process? The question is asking, what is the process? Okay. To separate D and L enantiomers. What is the process? That is resolution, dehydration, revolution, dehydrogenation. That is option number A. That is resolution. Okay. The method to separate T and L form from a racemic mixture is called as resolution. Okay. So option A. When chlorine is passed through propene at 400 degrees Celsius, which of the following is formed? Okay. Propene. Let's draw a propene plus chlorine at 400 degree Celsius. So what will be the product? Look, there is a chlorine molecule. So there is a strong possibility that it will it will resolve the double bond or dissolve the double bond and form a addition product. Okay, this is the common sense. But at 400 degrees Celsius, the addition reactions are not favorable. Which reaction will be favorable? There will be substitution reaction. Substitution reaction will be most favorable at 400 degree Celsius. So we have to find a major substitution product for propene. So for propene, there are three positions to be substituted. Here one, here one, and here one. So which position will be substituted? It is the sp3 bonded carbon, and it is sp2. It is sp2. Substitution reaction will be occurring in that position. In which position there will be the weakest bond present. Okay. So for the weakest bond, sp3 is the safest position. Okay. sp3 has the weakest bond among the other hybridization. So the position will be this carbon. So what will be the product? Okay. This is the product. Who? And this is called as allyl chloride because this carbon atom is adjacent to the double bond. Okay. So the option B is correct. Let's move to question number C. Sorry, question number 19. Two possible stereo structures of CH3CHOH, COOH, which are optically active, are called. Okay. So let's draw the structures. C, CH3, H, OH, and COOH. So is it a chiral compound? Yes, it is a chiral compound because it has one chiral carbon center. Which one is the chiral carbon center? This one, because all the four atoms or molecules are different. Okay, so two possible stereo structures. What will be the stereo structures which are optically active? As it is a chiral compound, it will form optically active isomers that are enantiomers. Okay, the optically active isomers will be called as enantiomers. Then we will move to question number 20. Which one is most reactive towards SN1 reaction? So let's recap the SN1 reaction first. Okay, SN1 reaction. Okay, so SN1 in SN1 reaction, the reaction rate depends upon only one product, that is the haloalkane or the other compounds. Okay, just one day. Then let's take an example, that is CH3 whole 3 CBr. This is a tertiary haloalkane. It is attacked by a nucleophile. What will be the mechanism? First of all, this bromine will be detached from the carbon and form a carbocation. So what will be the carbocation form? CH3C plus. Okay. So the most reactive nature of a haloalkane or haloarine will be confirmed from the stability of the carbocation form in the reaction mechanism. The more the stability of the carbocation form, the more reactive will be the haloalkane. Okay. So let's see from the options and compare. Okay. Question number A is C6H5. So the conclusion is carbo like reactivity in SN1 reaction, not in SN2. As for SN2, there will be other criteria. Reactivity is directly proportional to stability of carbocation. Okay. So for option A, the compound given is C6H5, CH, C6H5 and bromine. Okay. So the carbocation form will be C plus C6H5, C6H5 and H. For B, C6H5, H, CS3 and bromine. So what will be the carbocation form? C6H5, C, H, CS3 and plus. Then C, C6H5, C, CS3, C6H5, Br. Okay. So what will be the carbocation formed here? C plus C6H5, CH3, C6H5. T is C6H5, CH2, Br. So carbocation will be C6H5, CH2 plus. So let's compare the stability of carbocations. Okay. So all the positions here are benzyl position. Here also benzyl position. That is also benzyl position. It is also benzyl position, and this also benzyl position. So it will be stabilized by the conjugation of benzene with the carbocation. So the more the benzene more the benzene present, the more the stable will be the carbocation. So here two benzenes are present. Here one benzene, so it is ruled out. Here also two benzene present, and here one benzene, so it is also ruled out. We'll compare between option A and C now, because both have two C6H5. Now it will be dependent upon the third substituent, that is here hydrogen and here CH3. Okay, CH3 will donate its electron cloud to stabilize the carbocation more than hydrogen. So option C will have the most stable carbocation. So the carbocation stability is C greater than A greater than T and B. Between D and B, B will be more stable because of the presence of extra CH3 group. B and D. This is the stability of carbocation. Okay. So what will be the reactiveness? The reactiveness will be same order. C, A, B, D because of the stability of carbocation. So option C is the correct answer. Question number 21. Benzene reacts with CH3Cl in the presence of anhydrous LCl3 to form. Okay. So benzene reacts with CH3Cl in the presence of AlCl3 to produce. Okay. If you know a reaction, Friedel crafts alkylation and acylation. This is the reaction. Okay. But before discussing the product, we have to discuss the mechanism of Friedel-Crafts alkylation. Not only of Friedel-Crafts alkylation or acylation, we have to discuss the mechanism of electrophilic substitution reactions. Okay. So similar examples are benzene reacts with concentrated HNO3, concentrated H2SO4. That is like these mixtures are are called nitrating mixture. Okay, at 323 to 333 Kelvin, this will give a electrophilic substituent product. Okay, so these are the examples of electrophilic substitution reactions. So what will be the mechanism now? We'll study. Okay, mechanism. So first step of the mechanism for electrophilic substitution reaction. Ah. So mechanism will have three steps. The first step will be generation of electrophile. Second step will be formation of carbocation. Third step will be removal of proton from the carbocation intermediate. These are the three steps. Okay. So we'll write in the form of reactions now. So the first step is generation of electrophile. So what will facilitate the generation of electrophile? AlCl3. AlCl3 is a Lewis acid. Okay. So it will facilitate the formation of electrophiles. So like example, chlorine. Let's suppose chlorine is present. AlCl3 will modify it into C chlorine plus and AlCl4 minus. Okay. So this ion is called chloronium. In our focus, there will be CH3Cl. CH3Cl will be converted into LCl3, that is CH4 plus LCl4 minus. There is a formation of electrophile, that is CH4 plus. In case of acylation, there will be CH3C double bond O Cl reacts with the Lewis acid LCl3 to form a electrophile CH3 C plus double bond O AlCl4 minus. Okay, so these are the electrophile formed. Okay, so in case of the nitrating mix, like nitrating mixture, what will be the mechanism? HO2 SO H. Okay, H2SO4, right in this way. Then HNO3 will be written in this way. Okay, the lone pair present in oxygen will attack the hydrogen and the bond will be broken between sulfur and hydrogen. So this will be H H NO2 HSO4 minus. In step 2, in step 2, this bond will donate its electron to oxygen here and form H2O plus NO2 plus. This is the electrophile. Okay. So Friedel-Crafts alkylation, we got the electrophile as CS4 plus, sorry, CS3 plus, and for acylation we got the electrophile as CS3C plus O. Okay. So next step, what is the second step? Formation of carbocation or arenium ion. Okay. So what will be the mechanism? Let's see. This is the benzene, and it will be attacked by a electrophile, or benzene double bond will attack the electrophile. Let's suppose this will attack. So what will be formed? Just a minute. Let's suppose this double bond attacks the electrophile. What will be formed? A sigma complex. A sigma complex will be formed. That is, this double bond remains intact. Here, the electrophile will be attached along with the hydrogen, and here will be the hydrogen and positive charge. Got it? This carbon, and like this carbon is converted from sp2 to sp3 hybridized. Okay, and this is called as sigma complex. Okay. And this sigma complex, is it stable or unstable? Okay, it is stable based on the resonance mechanism. Okay, what will be the resonance structure, resonating structures here? This sigma complex He will be resonating. This carbocation will be stabilized by the resonating double bonds, that or conjugating double bonds. So the carbocation will shift here and double bond will shift here. Hydrogen EH. Again, this double bond will attack here and carbocation will be shift right here. Okay. So what will be the like resonating structure? That is the hybrid structure. That will be electron cloud will be from this carbon to this carbon. So the resonating structure is from this carbon to this carbon. Okay. It should be double like dotted. But I am denoting it in solid line. Okay. So we form the carbocation. Let's move to step number C. Step number C, that is removal of proton. Which proton? In this position, there is electrophile and a proton. So this proton should be removed so that only electrophile can be there and a double bond can be formed in this ring. Okay. So what will be the process? The benzene ring, the half benzene ring. Here is the hydrogen, E hydrogen, and AlCl4 minus was formed in first step. Okay. AlCl4 minus will like attack hydrogen here. It will it will accept the H plus and electrons will the bonds, two electrons will be formed here. This electron will then attack here to form a double bond. Okay. So the final product will be plus HCl AlCl3. Okay. For the HSO4, HSO4 minus electrophile, there will be HSO4 minus, let's write, for the nitrating mixture, the electrophile will be NO2 plus. Okay. But for that H2SO4, the sulfonation reaction, the nucleophile will attack. That is HSO4 minus. For all the other reaction, AlCl4 minus will attack. But for that sulfonation reaction, other HSO4 minus will be attacking. Okay. So this is the final product. For the alkylation, the E is CH3. So the product will be this. Okay. So we'll write the final reaction. Benzene reacts with CH3Cl in presence of anhydrous AlCl3 to form CH3 substituted benzene. What is the common name of this compound? That is toluene. Okay. So option D is correct answer. Let's write the name of the reaction. Friedel, Kraft. This is alkylation because alkyl group is substituted. So what will be the acyl reaction? Let's see that also. Let's suppose this is a benzene, CH3COCl, anhydrous AlCl3 plus heat. This will form COCH3. Okay, that is acetonone. This is the acylation because COCH3 group is attached. Okay, so let's move on to next question. Question number 22. Here the question number 22 given is incomplete. Okay, the options are incorrect. So what are the options? Which of the following compounds will undergo racemization when hydrolyzed by KOH solution? Okay, so what are the correct options? I searched for the question given in 2020 14 AIPMT. I got the correct question. So options given are C6H5 CH2Cl. This is the first option. Option B is CH2, 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 Cl. Option C is CH, CH3, CH3, CH2, Cl. And option D is CH3, Cl, C2H5, and H. Okay. Which of the following compounds? For racemization, we need to find out the chiral carbon. Okay, what? Uh, for like under hydrolysis reaction, this will be converted into the chlorine will be replaced by OH. Okay, so here OH will be formed. Here also OH. I'm writing the product part. Okay, OH and OH. Let's find out the racemized, like which product will be racemized. Racemized means there will be formation of two forms, that is D and L form. Means the compound should be optically active, and for optically active, active compound, we have to find the chiral carbon. Okay, for chiral carbon, this is not a chiral carbon because on the same carbon atom there are two hydrogen atoms. This also have two hydrogen atoms on a single carbon atom. So this is also not a chiral carbon. In this compound, CH3, CH3 are on the same carbon atom. So it is also not a chiral carbon. Look at this compound. This carbon has four substituents, but four are different. So this is a chiral carbon. So it will form optically active form, that is D and L form, and racemize. Okay. So option D is correct here. Okay. So let's move on to next question. Then question number 23. Chlorobenzene reacts with magnesium in dry ether to give a compound A, which further reacts with ethanol to ill. Let's write the equation series or reaction series. Chlorobenzene. This is the chlorobenzene reacts with magnesium in dry ether. Okay, in dry ether. Okay, what will be the product here? The magnesium will react will like this. This is the Grignard's reagent. Okay, it will react with ethanol. Okay, this benzene, magnesium bromide, will react with ethanol, C2H5OH. So product will be A. So what will be the product you are guessing? Yes, it will hydrolyze this compound. The alcohol will hydrolyze this compound, that is in this manner. This will be breaking into two phases, that is C2H5O minus and H plus. Then H plus will be replaced in this position and MgBr will be attached to C2H5O like this. Got it? So finally, benzene will be formed from chlorobenzene. Uh, uh, from chlorobenzene, the final product will be benzene. Okay. So let's recap the reaction. Chlorobenzene reacts with magnesium to form an organometallic compound, that is benzene MgBr, and it will react with C2H5OH. to form the hydrolysis product, that is benzene. So it can be a mechanical reaction for formation of benzene. Okay. So next, let's move on to next question. Which of the following is responsible for depletion of the ozone layer in the upper strata of the atmosphere? Okay. From class 6 or 7, you might be reading that for the ozone layer depletion, chlorofluorocarbons are responsible, and chlorofluorocarbons are present in refrigeration, like used in refrigeration. Okay. So the chlorofluorocarbons are the answers here. But in option A, B, C, D, there are no mention of chlorofluorocarbons. So, which name will be attached to chlorofluorocarbon, or which group will have the compounds like chlorofluorocarbon? We have to know. So, the freons will be answer, but we have to know that what are freons. Okay, what are freons? Freons are chloro and fluoro. Both will be there. Chlorine and fluorine. Chlorofluorocarbon compound of methane and ethane. In methane and ethane, if there is they like both, if there is a presence of both chlorine and fluorine, those compounds will be called as freons. Got it? What are the properties of freons? They are extremely stable, unreactive, non-toxic. They are directly non-toxic to us, but indirectly they are toxic by depleting the ozone layer. Non-corrosive and easily liquefiable. These are the some properties of freons. Example, let's take an example, that is CCl2F2, the freon of methane. This freon is named as freon 1, 2. Okay, and this will be formed by Schwartz reaction, form carbon tetrachloride or tetrachloromethane. Okay, so the answer will be freons in this question. Okay, so what is the mechanism? Chlorofluorocarbon CF2Cl2, that is CF2Cl2, CHF2Cl2. Notice there are both fluorine and chlorine present in a compound, so that we can call it as a chlorofluorocarbons or freon. CF2Cl2, CHF2Cl2, HCF2CHCl2. These are non-inflammable, colorless, stable up to 550 degrees Celsius. These are emitted as propellants in aerosol spray, refrigerators, firefighting reagents, and they absorb UV rays in the stratosphere. Okay, and produce free atomic chlorine, which result in decomposition of ozone. So these will uh, absorb the UV rays, and a chlorine free radical will be formed from this compound, and this chlorine free radical will deplete the ozone layer. Chlorofluorocarbons are chemically inert and hence do not react with any substance with which they come in contact, and therefore float through the atmosphere and as a result enter the stratosphere. Okay, so this is the answer. But before that, in this chapter, there are a very important chemical structure, like chemical compounds. We have to discuss about all of them because it will be asked in exams very oftenly. Okay, so compound is the first compound is dichloromethane. Dichloromethane, or also called as methylene chloride. You have to remember the common names because you can't without knowing, you can't draw the structure of methylene chloride. You will be thinking that methylene chloride is something about double bond. Okay, but methylene chloride is this structure: two chlorine and two hydrogen. Okay, so what is the properties of methylene chloride and uses? This methylene chloride is used as solvent for paint removing, propellant in aerosols, and manufacturing of drugs also. Then metal cleaning and finishing solvent. Okay, so these are given in your NCRT. You have to like read from NCRT line by line for organic chemistry. Okay, so these are the points given in your NCRT. Go through the NCRT again, and like if any information, new information is given there, write it down in your short notes. Okay, so the second compound we'll discuss is chloroform. You might have heard chloroform very oftenly. Okay, in movies, when we have to sedate someone, we use chloroform in movies. Okay, so what is the chemical name? Trichloromethane. Structure will be CCl, Cl, Cl, H. Okay, so what are the like uses and the properties? It is used as solvent for fats, alkaloids, and iodine. It is also used in the product used in the production of freon 22, that is R22. It is used as refrigerant. Okay, then most commonly before the invention of ethers or any other anesthetic compounds or elements, we were using chloroform as the major anesthetic agent. But due to its toxic nature and it is unsafe to patient, so we replaced it with the safer options like ether. Okay, so chloroform earlier it was used as anesthetic, anesthetic agent. Okay, so inhaling the vapors of chloroform will lead to sedation of central nervous system, sedative agent. Okay, then this chronic, if someone inhales or come to like chronic exposure with chloroform will lead to liver damage. Okay, due to formation of a toxic compound, that is phosphine. Because in liver the chloroform will be metabolized into phosphine, that is carbonyl chloride. Okay, The reaction will be CHCl2, O2, light, 2 COCl2 and HCl. Okay, so this is the reaction for this is the formation of fossil, the toxic compound. Okay, the next compound will be triiodomethane. In this compound, there is only one MCQ. Okay, the MCQ is it is used as antiseptic. It is used as antiseptic. Not now. It was used before. Okay, antiseptic, and the antiseptic nature or antiseptic property of this chemical compound is because of the free iodine, because of the liberation of free iodine, not because of the whole triiodomethane compound, but because of the liberation of free iodine. Iodine is the antiseptic. Iodine is the element which is giving antiseptic property to triiodomethane. Then tetrachloromethane, that is carbon tetrachloride or CCl4. It is used as like refrigerant. Okay, it is used in the refrigerant, propellants, degreasing agent, and like most important, it depletes the ozone layer. Okay, and the last compound is para para dichloro diphenyl. You have to remember the full name of this compound: diphenyl trichloroethane. That is DDT. DDT is banned now. Before the banning, it was used as organic insecticides. Okay, it was used as organic insecticides. It is not easily metabolized, and it affected the formation of egg cells of various birds. So that was the reason it is banned now. Okay, so the question number 15. Let's move to question number 25. Okay, question number 25. Chloropicrin is obtained by the reaction of. Okay, what is chloropicrin? Chloropicrin is nitrochloroform. Chloroform you have heard, but it is nitrochloroform, means that is NCCl3O2. That is chloropicrin or nitrochloroform. So what will be the reaction to obtain this chloropicrin? So the reaction to obtain chloropicrin is HCCl3, that is chloroform reacts with HNO3 to form CCl3O2, that is chloropicrin. This chloropicrin is very much poisonous and used as insecticide and can be used as a war gas. Okay, so this is the mechanism, that is uh, nitric acid on chloroform. Okay, option D is the correct answer. Industrial preparation of chloroform employ acetone and dash. Okay, so let's find out the like. Let's write the industrial preparation also and laboratory preparation for chloroform. For the laboratory preparation that is CaOCl2 will be used and it will be hydrolyzed. Okay, CaOH, laboratory and commercial or industrial. COH whole 2. The hydrolysis product will be Cl. Okay. This chlorine produced will be acting as a mild oxidizing agent as well as a chlorinating agent. Let's see how. It will react with CH3CO CH3 that is acetone will be reacted with chlorine to give CCl3 CO CH3. The hydrogens of CH3 substitute will be replaced by chlorine. Okay, plus 3HCl. This reaction is called as chlorination. Again, COCH3, sorry, CCl3, COCH3 will react with calcium hydroxide to form 2CHCl3 and CH3COO whole 2. Okay, so industrial preparation of chloroform employs acetone and phosgene, calcium hypochlorite, calcium hypochlorite, chlorine gas, or sodium chloride. This will be chlorine. The acetone and chlorine will react with each other alongside the calcium hydroxide in the last step to form CHCl3 or chloroform. So, correct answer is option C. This is not included in the reaction. It is just to form the chlorine like for the formation of chlorine. Phosgene is a common name for. Now itself, you saw that phosgene is produced from the like oxidation of chloroform. So what is the formula for phosgene? That is COCl. So this is a carbonyl group. So this compound is called as carbonyl chloride or phosgene. Carbonyl chloride or phosgene. Okay. Option D is correct answer. Let's move on to question number 28. Consider the reactions. Okay. It is also an incomplete question. So I'm writing the complete question here. What are the reactions? Reaction 1 and 2 are. The reaction 1 is CH3 whole 2 CHCH2 Br. I'll write smaller. CH3 whole 2 CHCH2 Br will react with C2H5OH to form CH3 whole 2 CHCH2 OC2H5 plus HBr. This is the reaction 1. Reaction 2 given is CH3 whole 2 CHCH2 Br C2H5O minus CH3 whole 2. Same product is like formed CH2 OC2 H5 HBr. Okay, so there are two substitution reaction given, but in the product is same in both cases, but the reagent used is different. That is C2H5OH in first question and C2H5O minus given in second question. So what will be the basis for uh, categorizing it into SN1 or SN2 reaction? That is the strength of nucleophile. Okay, strength of nucleophile or strength of solvent. In question 1, the nucleophile given is C2H5OH and it is a weak weak nucleophile. Weak nucleophile. In the question, like option 2, it is given C2H5O minus. It is a strong nucleophile. Okay. You know, for SNO1 reaction, we do not need the direct involvement of the reagent. So a weak nucleophile will be sufficient to go through the SN1 reaction. But in SN2 reaction, there is the direct involvement of the nucleophile. So you will uh, have to use a strong nucleophile to go through the SN2 reaction. Okay, so C2H5O minus is a weak nucleophile, so it will be undergoing SN1 reaction. As C2H5O minus is a strong nucleophile, so it will be undergoing SN2 reaction. So option A will undergo the reaction 1 will undergo SN1 reaction and reaction 2 will undergo SN2 reaction. Okay, so option A will be correct answer here. Which of the following reaction is an example of nucleophilic substitution reaction? Okay, we have to find the substitution reaction here. 2RX, 2NN, that is a Woods reaction. Woods reaction will form two like identical or symmetrical alkane. This is not a nucleophilic substitution reaction. It is a substitution reaction. You can say substitution reaction, but it is not a nucleophilic substitution reaction. It will undergo a free radical mechanism. Okay. Then second option RxS2 that will give like haloalkane reacts with hydrogen to form Rs plus HX. It is also not a nucleophilic substitution reaction. It is a substitution reaction, but it is not a nucleophilic substitution reaction. Then option C, haloalkane plus magnesium that will form a organometallic compound that is RMGX. It is not in substitution reaction. Okay, it is an moreover you can say addition, but it is not a proper addition also. Then option D, RxKOH that is hydrolysis of haloalkane with the help of KOH will produce an alcohol that is ROH plus KX. It is a nucleophilic substitution reaction. The nucleophile here is OH minus, and it will substitute the halogen present in the Rx compound. Okay, so option D is the nucleophilic substitution reaction. Okay, so this was the last question of the session. Okay, the question number 29. It was the last question. So we have solved 29 PIQ of this chapter. So we have almost covered all type of question in this chapter. So go through all the questions again, solve by yourself again without seeing the solution, and revise the short notes or revise the reactions mechanism, the uh, physical properties, chemical properties of the all the haloalkane derived products given in the last two pages of the NCERT chapter. Okay, so let's end the session here. Thank you.